So, wonderful good afternoon, dear LinkedIn community, Composites Lounge members, and Composites experts out there. Today, we're talking in the third edition, which is already the third edition of the Composites Lounge Engineering Talks, today about the sporting goods industry. Now, the sporting goods industry lately, I was at the ISPO in Munich. This is an international sporting goods exhibition. I was really amazed about the variety of composites that are more and more penetrating in the sporting goods industry. And therefore, I really thought let's take the sporting goods industry today as a topic, because the variety is vast, where composites can really benefit in the sporting industry. And we will make, however, a deeper dive into one kind of a sporting technology, and that is the typical classical bikes. And not only bikes, you know, the alu bikes, you know, the carbon composite bikes. Today, I will present you a fully plastic bike from igus. And we have here today a team of developers, product managers, how you call that, and market responsibles. And I will introduce them to you just right after this video. So have a look. It's 2 minutes. And after this 2 minutes, we will start with our Composites Lounge Engineering Talks. Meanwhile, by the way, write down in the comments from where are you attending today our show, because we want to see the reach. And do you have sporting goods manufacturing in your plant? What composite processes do you use? Write them in the comments. We'd love to hear from you. And now the video.
Wir wollen das wartungsärmste und nachhaltigste Fahrrad der Welt bauen.
Da haben einige Leute sich umgedreht und auch gefragt, was ist das, oder das kommentiert.
Plastik rostet nicht, Plastik braucht keine Schmiermittel und Plastik hat eine hohe Lebensdauer.
Plastics, it's the future.
Viele Leute halten uns für verrückt, aber das treibt uns noch mehr an. Mein Name ist Sven Terhardt, ich bin 30 Jahre alt, bin begeisterter Fahrradfahrer, habe nach meinem Studium zum Wirtschaftsingenieurswesen in Amsterdam gewohnt für 3,5 Jahre und nun betreue ich das Projekt, ein Kunststofffahrrad, wo wir nochmal ein Fahrrad ganz neu denken wollen. Ein Fahrrad neu zu erfinden ist nicht so einfach. Wir stecken seit Jahren in der Entwicklung und stehen kurz vor dem Marktstart. Wir haben hier in Köln eine Produktion aufgebaut, um die Idee des Kunststofffahrrads umzusetzen. Momentan besteht das Fahrrad aus ca. 92% Kunststoff. Das Einzige, was nicht aus Kunststoff bzw. Plastik besteht, sind Verbindungsstücke oder auch die Tretachse und die Bremsen. Unser Ziel ist es zum Beispiel bei den Bremsen auch eine Kunststofflösung auszuprobieren. Da sind wir noch nicht, aber wir arbeiten dran an diesen verrückten Ideen. Wir wollen das nachhaltigste und das wartungsärmste Fahrrad der Welt bauen. Wir haben die Möglichkeit, dadurch, dass alles aus Kunststoff ist, hier bei uns in der eigenen Produktion in Köln herzustellen. Also sparen wir so Transportwege. Außerdem ist Kunststoff bzw. Plastik energieärmer in der Produktion als Aluminium. Und Plastik kann nicht rosten und benötigt keine Schmiermittel. Und darum machen wir das Fahrrad aus Kunststoff.
So, dear community, you have seen this is igus producing bikes, and let me greet now in clockwise order. We have here Marc Siebert, who has been attending our Composites Lounge talks already prior since the beginning. Marc is a professor at the PFH in Göttingen /Stade. an expert in composites. Then we have Jan Philipp, and I will talk to Jan Philipp soon about their business models and how I just came to, start producing bikes as a plastics component manufacturer. Then we got Sven, and Sven, as you've seen, is our superstar. And thank you so much for ARD and MDR for filming Sven. So I've borrowed this video from YouTube, and we will talk with Sven more in detail about this bike production. Then we have Arne from sensXPERT. Arne is replacing today Dominic. I've announced Dominic to you guys, but Dominic currently is not available, so Arne is taking his seat here today. sensXPERT is supporting this Composites Lounge Engineering Talks. Actually, they're our main partner on this series of Composites Lounge Engineering Talks. So thank you, Arne, for representing our partner today. And then last but not least, the legendary Yannick Willemin from Zurich, Switzerland. And with Yannick, I would like to... So with Arne, we are going into the material side. With Marc and Jan and Sven, we will go into the biking industry. And with Yannick, I would like to zoom out again and have a look what other applications are there for composites in the sporting goods industry. So this live will be about 12 p.m., maybe 12:10, something like that. If you cannot watch this live in its full length, don't worry, we got you covered. You can always come back after this live and watch it here on replay on LinkedIn, YouTube, and next week you can listen it as a podcast right now. So without further ado, then I will take now Arne into the picture, and with Arne we will be talking about the material side. So, Arne, thank you so much for being part of our show today. As your company is very much involved in AI, let me ask you, as an AI company, what did you find out? Why are composites so important in the sports industry? What is your view on this?
Yeah, thank you, Ilkay, for having us. Let's say when it comes to sports and sports goods, composites is maybe the best material solution which is on the market. If you ever been on a bike ride in the Alps, you know that weight matters. And especially carbon fibers, composites gives you the best lightweight potential. But let's say lightweight is only one side. The other one is the mechanical properties of these excellent materials. So you have very high stiffness, very high strength at this low weight, but it's also the design of the material itself. So you, with choosing the right fiber orientation in your product, you can steer the stiffness, and therefore you can decide where you want to have a very stiff part, for instance, in your bike frame to have the highest performance, but also a more flexible areas to provide more comfort. So it's probably the best material out there to make sports goods.
Okay, so the sporting good industry, do you also feel that the applications are becoming more and more? How's your feeling?
Yeah, definitely. You see that more and more. I mean, I ride mountain bikes and road bikes for 25 years now, and you see this material more and more in the frames, in the handlebars, even the saddles. You see the composites being used, and you also see a drop in cost, but still it's kind of costly material. So there is space for improvement, let's say. And this is also where we came in place to optimize this kind of production process to lower the cost using latest sensor technology and combine it with AI.
Mm-hmm. But I'm always also trying to see the downside or the limits of the materials. Now, one of the limits I have seen with carbon bikes, I'm not now saying specifically plastics because that I don't know yet. We will learn about that today. With the composites materials, always these junctions are a specific bottleneck, how to get these pipes joined together. And maybe that's something we will discuss also with Marc later on. But from your view, what other challenges do you see in the manufacture of composites in the sporting good industry?
Yeah, excellent question, Ilkay. I mean, it's a very cost-driven industry. It's a more or less B2C market, and there's a high pressure on the costs. And that is also related to, let's say, production time, cycle times of the curing behavior of these materials inside the mold. And this is where sensXPERT helps. So we developed sensor technology to monitor the curing behavior inside the mold. And in combination with analyzing the data coming from the machine using machine learning AI, we bridge this gap between part quality and process parameters. And with this, we can reduce cycle times, reduce scrap, and make the production more sustainability. So to have a brighter usage of composites in the sports industry, it's really important to lower the costs.
So once we know the pain point of the manufacture, cost of manufacture, I'm sure you have some solutions in your mind. So what would be a solution? How could sensXPERT bring cycle times down and cost down? What would be your suggestion here, or what's the best practice to do that?
Yeah, I mean, we already saw and we'll hear about new technologies that come to the market. But if you look to the state of the art, how composites are used in the bicycle industry, or let's say in the sports industry, it's mainly based on thermoset matrices and the typical production methods like RTM, autoclave curing, and so on. And if you look to these processes, they have very long cure cycles, sometimes an hour, 2 hours at 170 degrees. You have to store the pre-preg materials in the fridge at minus 18 degrees Celsius. And of course, this is quite cost intense and brings also, let's say, certain variation to the manufacturing process coming from the material, because it tends to pre-cure during storage, during the supply chain, and so on. And how sensXPERT could help there is by monitoring the curing behavior inside the molds in the state-of-the-art manufacturing processes. We can lower the cycle times by 30%, because there are still some safety margins in these processes, because it's also safety-related components. And there is the part where sensXPERT can contribute by monitoring the curing behavior inside the mold and bridge the relation to the process parameters during the manufacturing. We can lower cycle times by up to 30% and reduce the scrap, sometimes even by 50%.
Okay, these are massive numbers, I would say, and really worthwhile looking at them. Okay, thank you so much, Arne, for your introduction into the material science of the sporting goods industry, which is always the starter. Before we delve into the end-use applications, we have to understand the processes. Community, please write in the comments. I'm seeing some activity already coming in, and I will show your comments and we'll read your comments and discuss your comments soon with the panel. So in the meanwhile, please write in the comments from where you're tuning in. What is the process? What is the end-use application you're having with composites? And we are glad and thankful that you are watching this live here right now. And I will now press the play button on a short trailer. And just after the short trailer, we will talk with Jan about the business model of igus and how they came to the idea to produce bikes and what else they are doing. So stay with me right now on this video. Composites Lounge, Ilkay Özgüzoğlu, creating sustainable value today from Istanbul, where people see thought leaders bringing up the latest topics and trends, particularly in composites, industry, and advanced materials. We are seeing people working on sustainability and the future. To this end, welcome to our 2025 episodes of Composites 360 on tour. We bring you the brightest minds influencers, and subject matter on your screen. With live panels at subject exhibitions, we are here to serve you with the latest content that is available in this industry. Whether it is aerospace, automotive, whether these are regional events like here in Istanbul, in Krakow, Poland, in Paris, France, or Germany, it could be also in Italy, we are here to cover those events in order to bring you the most pressing ideas and the most creative ideas to create sustainability and connect the global composites world. We invite you to join our Composites 360 on tour. I bring you the brightest, the best, and the farthest topics on LinkedIn.
Ilkay Eskisolu, Composites 360 on tour with Composites Lounge weekly on LinkedIn, YouTube, and your preferred podcasts.
So, dear community, as you see, this trailer is about Composites 360 on tour, and let me shortly explain you small Eigenwerbung, we say in Germany, advertising for Composites Lounge before we dive into the topic. So, Composites 360 on tour is our alternative format where we are going onto events and putting companies, manufacturers, experts, influencers, the brightest minds into the spotlight. We will be at JEC World in the beginning of March. That's the 4th, the 5th, and the 6th of March, and have a fantastic program already lined up. So stay tuned on what we will show you. If you want to join our spotlight, Composites 360 on tour, drop me a message, and we're happy to come and interview you guys on the show floor. So now this is enough advertising for us, and let me now add Jan Philipp Hollmann to me. Jan is right now in his office, he said to me. Jan, can you explain me what kind of office are you in there? Because I find that fascinating.
Well, it's hello everyone. It's a office style, which is very close to our fabric side as well, and we tend to have the same architecture all over to have everything very flexible, which is always of big help to shift working spaces, but also machineries within the factory. So yes, I'm in the middle of the production side.
Which is really unusual, but I like it because I always want to get the feel of and the vibes and the energy of the production into our show. So thanks so much that you've specifically selected that place. So Jan, before we go into the business models, for those in our community that may not know igus well, how would you describe igus? Just tell us a few words about what is igus about, what are the solutions, what is their mission, what is their vision, just in a nutshell.
Happy to do so. Well, as you just seen in the video where Sven took part, at igus it's all about plastics. Yeah. So our specialty is plastics, and there with the focus on motion plastics, with the benefit of loop-free products that enable companies to use plastic instead of metal for many different applications. So for example, bearings, that's one of our specialty, but also energy chains. The overall product portfolio covers over 250,000 products in total, but the key focus is on improving what moves with the plastic components that are maintenance free, lubrication free, and lightweight. And aside that, we also now have this new business unit with bicycles. So the igus bike or resale bike, which you've seen in the video, which is a 100% development by igus itself. So in-house R&D for a new era of bicycle. So the benefit of this bicycle is to have a recycled plastics motion bicycle, but also with all the benefits of the key, let's say, DNA of igus, maintenance-free, lubrication-free products to have a benefit for the environment and 100% recyclable material in use. So this is one side of the product category within the business unit of bikes. And then we also have this new industry, which we want to provide with solutions as a tier 1 provider for bike OEMs. So here in the back, you can see our first injection molded frame which is our, let's say, new product category to have injection molded, high performance composite components for frames, handlebars, forks, cranks, and many different more products that are required within bike industries. So you might ask why we move towards this step towards becoming a bike tier one manufacturer, since we are very, let's say, specialized on smaller parts, but which are like, we are more or less a hidden champion for these with a global footprint. But during Corona, everyone noticed a rising, let's say, growth for bicycles. The transition of mobility was taking place and is being initiated. But at the same time, with this huge demand, the bike industry also suffered a, let's say, collapse of their supply chains. The dependency on Asia is very big. So over 95% of the components are being delivered from Asia. And there we saw the entry ticket for us, being specialists for composites with over 800 injection molding machines here at igus, but also the experience in the bike industry with the bearings, but also the igus bicycle itself, to offer something new to the industry with a local to local approach, made in Germany or Europe, with a new innovative product using this fantastic technology of injection molding, with this new product category that offers a new product world for bike OEMs, but also this independency from Asia with local supply chains, transparent supply chains, a new standard within quality, which is more or less based on the effect of the injection molding technology, which allows you 100% precise tolerances and these repeatable. So almost automotive standards for the bike industry, which is a new level that can be approached with this.
So that's really fascinating, and I've never experienced a bike fully from polymers, plastics, and this is really a disruptive technology. So I think in your website you even say after aluminium and after carbon, now is plastics time.
Yes.
And I see some benefits there, because plastics is corrosion free. Let's take lightweight on the one side, which is the classical feature, but on the other side is also the corrosion freeness, and I think that has some merit, especially in places where you have a corrosive environment. What comes to my mind is maybe holiday resorts at the seaside, sea level. Yeah, you want the bikes to look fresh, look nice, and colorful, like my pullover here. Yeah, in your igus color, or Nile igus color. Almost, yeah. So I see there some benefits, and I think now is the time to take also Marc on board. And Marc will be now moderating. I will hand over the moderation to Marc, and Marc will be moderating both Jan and our YouTube star Sven. I hope you understand my my compliment here, Sven. Yeah, because you did a fantastic job with the video. So if you have joined our LinkedIn Live at a later stage, Sven has been featured by the German television, and there is a YouTube video on this, which I showed just the beginning. It's a 24 minutes video. It would explode this stream today to show you the 24 minutes. Go into YouTube, search it, or go back to the beginning where I'm showing the first 2 minutes. So
thanks, Ilkay.
You're welcome, Sven. So Marc, then I would say you take on and moderate this intensive deep dive into the bike industry.
You're muted.
You're muted.
Marc.
So now you can hear me. Perfect.
Yes.
So I fully agree, Jan Philipp. I work for the bicycle industry since around about 30 years, and reproducibility, that's a big thing. So I know it from not only from the beginning. The principle was trial and error. So we need something, let's do something. Up to a certain performance level, that was okay. But then the material changed from aluminium to carbon fiber. And then it started once again with bigger problems. So nobody expected that kind of problem. So I like what you do. First question is, you are in the field of plastic, yes, but to become a supplier for the bicycle industry, so that is a very, very special market. Where did the idea come from? Was it from your owner, or how did it start? So for me, it's not clear to say, okay, we do plastics, let's do bicycles.
And Philip, do you want to? I also can reply to that. We are already since 30 years in the bicycle industry with our bearings, means in shifting systems for the derailleur, for example, you have our bearings. In brakes, when you press the handle, there are our bearings in. And then that's already 30 years ago when we started with this. And then 20 years ago, our CEO went on holiday and he rented on a beach bikes, and then there's a really salty sea wind, and the guys who rented the bikes out, they said, yeah, we always need to exchange parts every 3 months. And the first time the idea came in, and then in 2020 we found a partner in the Netherlands, Material, and then they were also doing plastic bikes, and then we worked together with them on the full plastic bikes, which you also saw in the video. And we are also doing this full plastic bike to get ideas actually for the market, and that's how the full train started. And now we are also producing frames for the market, for example, in injection molding technology.
So okay, so I would suggest to go on with your division, Sven. So the complete bike. So you know, I ordered 2 bikes for university, and the question is why. So on one hand, I collect bicycles, and I'm a bicycle enthusiast like you too. So, but that's not the main reason. In the video, we saw the front hub, for example. And if we talk about education and how to get knowledge in composites or materials, so you realized the front hub in a full plastic design with all the benefits you talked about. What is necessary to come to that final result? So we must talk about material properties. So on one hand, it's passion for cycling, okay, but to reach a high level, we need more than passion, and we need material properties. So, and if you compare your plastic hub with the classic hub, we see big differences, and it must be like that because the classic hubs are made of metals and they have different properties. So that is so the bike is a very good demonstrator, and for the cranks we can see the same. So the shape of the cranks is different. The cranks are cranks, but they look different. So, and that is very, very interesting. So let's come to the bike, to the whole bike. How many bikes can you produce in 1 year with your process?
We need to divide it in 2 sections. We have the big parts, the frame, fork, and wheel, and they got produced in rotational molding, means that is completely different than injection molding. That is a low pressure process, let's say, and there we have the possibility to produce up to 1,000 frames a year. I think even we have a higher capacity if we want, because we have quite cheap toolings. And the other parts of the bike means the ball bearings here with glass balls, but also the crank and the stem and all the other parts are made by injection molding technology. And yeah, this is of course a technology where we can produce thousands of pieces or millions of pieces in 1 year.
Yeah. So let's go a little bit more into detail of the process. You talked about rotation molding. So I would say everybody knows more or less injection molding, but not rotation molding. Can you explain the process a little bit?
Yes, you can. It's a bit like the production of chocolate Christmas man. You have a form, and we don't use granulates for that. We use powder for that, and you have a form, and you get the powder into the form, and then the form gets heated up from outside, and it turns around, and that's how we get the flow, and then the powder melts, caps to the outside, and that's how we get the hollow bike frame. We are not using fiber materials, or we do composites. We're using plastics HDPE, really easy plastics, 50% recycled for this, and that's why we have a bit of different structure than the smaller frames, for example, which Philipp has in his background.
Yeah, so that means the igus, the whole bicycle, is it without any fiber reinforcement, or does it depend on the process and the components? So the big ones, so frame and fork without a fiber reinforcement?
Frame, fork, and wheel without fiber reinforcement. And some other parts, we do not like to speak so much about materials because this is one of our biggest strengths. But some other parts are, for example, for the cranks are with some fiber reinforcement. Yeah.
Okay, so then we can switch to Jan. So now we talk about with you two about a little bit about injection molding. I think the process is more or less clear. So we have a mold and we inject liquid plastic into the mold, and that's it. In scale, it's not like that. It's a little bit more. So if you talk about fiber reinforcement, it is a little bit more. So we see the frame behind you.
Yes.
So I would say it's a very complex shape if we talk about injection molding. And typical for injection molding is that the fibers, there is a flow in the mold, and the orientation of the fibers depends on the flow of the liquid plastic in the mold. So what can we expect? Is it possible to influence the direction of the fibers?
Well, to a certain amount. But first of all, the frame you see behind me, the benefit of this frame is it's, yes, with injection molding technology, fiber reinforced product, but the difference is towards conventional, let's say, production of frames, that you have the super smooth surfaces, no welding lines, and a one piece that drops out of the machine. And this is why we actually use the injection molding technology for this new product development and production technology for frames. But as you mentioned, Marc, fiber reinforcement, yes, and fiber direction. So in general, it is a rather complex process where we need to manage many different processes within this. So first of all, we start with the design of the product. The product needs to be developed in its layout so that it fits to the requirements of an injection molding product designed for plastics. Then we prove this with FEM simulations, mold flow simulations. You have to simulate the flow of the melt. Filling studies, and with these you are able to see, okay, how is the melt and the fibers direction flowing to control it. It's rather difficult or impossible to have different directions of fibers, and this is also not the intention with our fiber reinforced products. For this, we would you would rather use organic sheets with endless fiber organic sheets that have this multi-directional coverage, but with our short fiber reinforcement, we are able to achieve stiffness rates that are equal to an aluminium frame already. So and one final thing which I'd like to highlight is that with all this, at the end, it's all about testing, and this is something where igus has put a big focus on since its generation 60 years ago. to test these products and to see, okay, how is the product really in performing in real life, because every simulation and layout can be a good indication, but in the end it's all about testing, and then we learn. You're muted. I cannot hear.
Oh, no. So you talked about mold flow. Can you tell us how many injection points do you have for such a frame?
For the current one, which you see in the back, we have 4. But there are also other frames that used 1. We have we've made the experience that with this 4 injection points, it is better to also move the welding lines and to have no let's say risk lines within the frame. But there are different technologies. I mean, we do the conventional technology, including sliders. So we have very big tool. So the tool for this frame is 20 tons. And then we have a very complex slider technology for the battery case, for the rear triangle, for the head tube, which even cross each other during the process. So it's a very complex, but therefore in the end very precise output of the product, which has this perfect shapes and 100% repeatable tolerances that are then being possible with this fantastic technology.
Yeah. So it is a hollow structure, and you talked a little bit about the mold now. So so the sliders and so on. So I see it in the background. So more or less no problem to get a core, a mold part into the down tube from the bottom bracket side.
Correct.
And to get something like that in the steering tube, no problem, more or less no problem. To get something like that in the C tube, more or less no problem, because it's open on top and to the bottom bracket side. But how to manage it for the top tube, for example, and how to manage it for the chain and the seat stays? How is it possible to get these sections hollow?
It is possible, but that's a technology that we don't focus on, to either use gas or water injection. What we have, our experience with that technology is that we are not able to. The bigger the diameter becomes, the more complicated it becomes to press out the remaining melt that's inside to create a hollow structure, and also the surfaces are not that good from the inside. What we have done for this at this frame, for example, we have a T structure for the or C structure for the top tube, which makes it hollow from beneath, and also for the chainstay, which you see on my back. Underneath, we have an extra line for cable routing. Yeah, so therefore, this way you also reduce material, and also the with a specific insert within the tool, which makes it possible to integrate this.
Yeah. So we need the cable infrastructure because the customers want everything inside the frame. So that means, and this kind of infrastructure, the channels are, more or less the whole. So okay.
And that's why always what I say is the composite, the use of composites with the injection molding gives bike OEMs a new access to design for assembly, design for maintenance, because they want everything to be cleaner. The design is a very big topic with the bike industry nowadays because of the rising amount of the bike, but also towards maintenance. Yeah, to have cables integrated, yes, but how can we integrate them in a smart way to have an easy access to them again once they break or have a default? And this is where injection molding jumps in with the different abilities in the layout and design of components.
So then the same questions like I asked Sven, how many frames can you manufacture a year?
Oh, that's a lot. So you have to compare. Injection molding is a serial production process, which is a very popular in automotive industry due to high volume and high quality. With injection with the motor molding, it is a I want to say low cost, but the tools are cheaper, but it also takes longer for production. So, example, frame with the rotor molding is 20 minutes. Injection molding, entire process, it's 4 minutes, or even less, depending on the complexity of the frame. And then it depends on how many shifts you have working, but it's an automated process, so you can have it actually running 24/7, and this is the benefit with the automation possibilities with the use of composites and our technologies like rotor molding and injection molding. So it's millions, to answer your question.
Yeah, so you're able to do millions. Yeah, yes. But let's come from the brand side. Oh, there's a bicycle brand, and they want to have such a frame. What is the minimum amount of frames that it may? Where does it make sense?
Well, that certainly it's a technology for serial production, but it's always towards what's the comparison in the end. So if you compare it to a very low cost aluminum frame, yes, well then it's not, then the benefit is not, or the benefit is not that close. But when you compare it to a high class aluminum frame nowadays, the shapes outside aluminum frames are being reworked, reprocessed, including putty, which is a harmful material as well. When you compare it with that frames, you're now able to resource a frame in Europe, in Germany, locally produced, and when all this is being involved in towards the calculation, then you do have an investment that makes sense for the future direction of bikes made in Germany.
Okay, so let's go on talking about cost. So you have the frame, and for the next season, the customer wants a slightly different shape, because the frame of the 26th generation should look a little bit different. Do we need a 20-ton mold again to realize it?
No, that's what we are working on and focusing on, to set up modular tool settings to have the ability to exchange certain parts of the frame, and also to have it grow in a dimension, so that you do not need a tool for every size, because that was a bottleneck in the past, to have a tool set for each size. And this is what we are working on, to have a modular tool approach, allowing small deviations and also design changes, but also different sizes, which are still necessary and required for bike customers.
Okay, very good. You compared your frame to aluminum frames. So so aluminum, you talked about it, or Sven talked about it. Sustainability. We know aluminum is recyclable, but and this is the argument in most cases, it is recyclable. But if we look at the amount of energy we need to do it, we say, oh, it's a lot. On one hand, yes, we can do it, but does it make sense? More or less, no, in a lot of cases. Is it possible to recycle your frames?
Yes, it is. So either with the igus bike, which already includes 50% recycled fishnet materials in powder form. So here you have the direct example what is possible to reuse materials that are waste or classified as waste, and then get back into life, and this for mobility, to support the transition of the mobility. And also with our components, it is possible. We are starting to use recycled material in first place. That the product itself has a high share of recycled material in first place already, but also the 100% recyclability of components or composites that's possible. And this is also what we are working on. So I can give you the example here at igus. We have energy change, which is one of our core businesses, and we offer all customers to resend them to us once they have reached end of life, and we then give them to our recycling partner, and we reuse the material again in a cradle to cradle systematic, so that we are able to reuse the entire material on a very low emission based scenario. And this should be the vision and the long-term goal of the entire industry, because I mean, plastics is not new. We have thermostats, which is also plastics, but it's non-recyclable. And with thermoplastics, which is the new category, but we are offering, you do have material that is, yeah, lightweight and 100% recyclable, which are key benefits.
Yeah. So can you talk about the material, so the matrix material especially? So it's reinforced with fibers, so we have short carbon fibers in the material. Sven told us for the igus bike, it is PE for some components, but for the injection molding components, it's not PE. So what kind of base material is it? Can you talk about it?
Polyamides, but as Sven mentioned, it's at igus, we are very, it's like a Coca-Cola recipes with our materials, especially also for bearings. You have to have this benefit for customers and that they enjoy these benefits that igus has with its in-house material science. So this is one key, unit within igus, the material side, to develop all materials for best products to either, let's say, improve the movement or motion, or having a benefit on their, let's say, cost side to save costs. And this is also what we want to approach with our bike components, to have something new and an innovative product, either with a full bicycle or with the components, to provide a benefit for customers.
Okay, so around about 2 weeks ago, we had an event from Composites United Network, and we talked about sporting goods too. And one speaker told us about thermoplastics in bicycles, and it was 15 to 20 years ago, and it was all not successful. And one thing was the behavior at higher temperature. So we can talk about the glass transition temperature. So a question to Sven and you, for the frame in your background, Jan, can you talk about glass transition temperature?
That's an important point you're mentioning here. And yes, these are the, let's say, the remaining, open questions for many customers with regard to plastics when it comes to high temperature or low temperature. And as I mentioned earlier, what we do is we set a high focus on testing. So we have a test lab, which is over 250 square meter only for bike components here at igus. And we have tested the frame and handlebars and other components in our, let's say, fridge, which goes down to minus 40 degrees. And we do the pedaling test, the impact test, so all the relevant tests that are required for bike tests, and also under humidation, so with heating, but also in wet and humid surroundings, to cover all these different surroundings. And yes, there are limits. So if you ride the bicycle in a surrounding of 120 degrees, it could become a little melty. But I've not met the person yet who's done that. So we are in a position to say that up to 60 to 80 degrees, we are all set, and also down to minus 30 degrees, what we have tested with the composites. I hope that answers your question.
Yeah, thank you. Sven, same question to you. So if you talk about PE, it's a little bit different. Yeah.
That's correct, but also there we test everything. It's also in the norm. We test minus 20 degrees and up to plus 80 degrees. And that works really well for all the parts which we designed. But for example, we had to reshape the wheel, because in the heating test with our first wheel, we had some problems during the heating test, but we reshaped the wheel, and now it works. Means, and also how we design the parts, that gives us information, or that helps us to overcome these problems.
Okay, then a question to Arne. Arne, you talk about how to steer. So first, how to monitor processes, and then how to steer or influence the processes. So it should be a good combination, sensXPERT and igus. Are you in contact?
Me personally, not yet. So I'm very glad for today's event here. and to meet the people from igus. Let's say we also have experience with injection molding, also on thermoplastics. And I was also glad to hear that you are using a lot of recycled materials. Because when it comes to recycled materials, typically these materials can influence the process by bringing variations coming from the material itself. I mean, these materials have a certain history and they are not behaving like virgin materials. And here our sensor technology comes into place. So we would install a sensor in the mold and we would monitor the, let's say, classification behavior inside the mold. We can also track the crystallinity of semi-crystalline thermoplastics. And with this, we can steer the process. So we can detect how certain process parameters like pressure, temperature, and so on influence this crystallinity, for instance. And then we can also advise or give advice how to steer the process to still produce high quality parts, even if the material behavior changes a bit.
Mm-hmm. So we have with the injection molding or with rotation molding too, we have a lot of data, and the more data we have, the more sense it makes to let you look at it. So analyze it, monitor it, analyze it, steer the process to come to the best reproducibility possible. So
yeah, right? Exactly. I mean, even if you have a lot of data, you get easily lost within this complete wood of data. And there, of course, our machine learning algorithms help to understand the data better and to bridge the relations between process parameters and part quality. And also to add, I mean, you can extract a lot of data from the production machines like injection molding machines, but there is also the key element, how does the material react to the treatment inside the mold? And therefore, we also add, let's say, the sensor technology to our AI algorithms to also have the information how the material reacts to the treatment. And especially this is a valid point if the material change over time, which is typically the case if you're using recycled materials.
Mm-hmm. What is, so you talked about RTM processes and other composite processes, autoclave and so on. I would say for a hand laminating process, it makes no sense. So you need data. How much? When makes it sense?
Yeah, I mean, it makes all the time sense when you want to reduce cycle times. If this is really one of your bottlenecks, then it makes sense to have more insights of your process to understand how the curing cycle happens inside your molds. Then it's let's say in USP for our technology. And the other one is changing materials, variations coming from the materials. I mean, if we talk to the, let's say, state-of-the-art technology using thermosets, these materials need to be cooled over time, over the complete supply chain. And if as soon as you take them out of the fridge, they start to pre-cure. And this brings a certain variation to the process and can lead to quality issues, short shots, some surface issues, and sometimes also by a decrease of mechanical performance of these materials. And there we can help to understand how the material reacts and then also, let's say, adapt the process in an automated way that you have an optimal cycle time and still meet your quality requirements.
Okay. Then a question to Ilkay. Do we have some question coming out of the chat?
Yes, good point. We will make a short break, a trailer, and then we will back and take all the comments into the screen and ask and answer all these questions that have been coming up on the lively chat that we are seeing down there. See you in a minute.
The hard work of Composites teams should be shouted from the rooftops. We're on a mission to give your solutions better visibility and reach, to make them more widely known in the market and gain the appreciation they deserve. To make lightweight construction and specialized technologies available to end users, as well as attract projects, customers, and talent, join our Composites Lounge community. The Composites Lounge community is open to entrepreneurs, C-levels, specialists, and managers who want to create a better world with their innovative composites and play a key role in the success of their company. So if you're a hidden champion who isn't sure how to best promote your work, join a supportive and innovative community, which is focused on making composites achievements visible to end users. The Composites Lounge community celebrates and promotes the best innovations, lightweight construction technologies, and sustainable solutions in the automotive, aviation, renewable energy, oil and gas industries, and many more. Get involved at compositeslounge.com.
So here we go, Marc. Compositeslounge.com. Everyone who wants to be featured on Jack World, please get in touch with me. Marc, so we have a few questions and comments and also visitors. Let's go one after the other. So Abdullah is saying that he has started up the composites bikes in Turkey under the registration of Zero Light, and they are using pre-preg material and curing them with a hot press forming with a pressurized bladder. So we are in the scale-up phase, mticomposites.com. Yeah, what I wanted to know from you is the pre-preg technology. Are we sure that pre-preg is the best and the optimum?
It's a good question. For some products, yes. So we talk about fiber volume fraction. So that means the content of the fiber in the whole composite, and that is some kind of a quality criteria. By using pre-pregs, we can get a high level of, or we get a high fiber volume fraction. So in some cases, 65%, something like that. So we can say, yeah, it depends. What about your customers? What kind of product you want to manufacture? For a high-level product, in a lot of cases, we need pre-preg to reach the goal. Medium-level product, we can use alternative processes. So I would say yes. On one hand, the pre-preg it's a high-quality material, and we find it in a lot of sporting goods. So at our CU event, we had people from the racket industry, so tennis rackets, other rackets. They mainly use pre-preg to do their products. They work on other processes, yes, but yeah, we must discuss the material properties. So pre-preg in most cases means endless fiber composites. Injection molding means short fiber. Sometimes we can combine it with long or endless fiber sections. So then we talk about, it's called over molding. So we can start with an organo sheet, and we can use the injection molding to bring some ribs or some functionalities on that kind of organo sheet. So that is an interesting technology too. So yeah, it depends what performance level your product is.
Okay, then we go on with Giorgio from Italy. So he says he's working on an Interact project about the recycling of composites waste from urban areas, mostly sports equipment. So Giorgio is basically pointing to certainly an issue that comes in the future. What happens with all the sporting goods at the end of the life?
Yeah, that's it's a good question. So with some colleagues from Switzerland, we developed a recycled carbon fiber bike too. So different from what we see from igus. So it's a high performance road racing frame, looks very similar to classic road racing frames. And I was not an expert for the recycling material. My expectation was it's no problem to get the material. And they told me, how much do you need? 2 kilograms for a frame. So, oh, it's hard. So 2 kilograms. I expected it's no problem to get that kind of material, but it is. And he talks about it. To get it back, that is the problem. How can you get a damaged frame, for example, or a tennis racket back from the customer? So we have to work on it. So on one hand, we have the technology, so we can do recycling of carbon fiber. That's not the problem, more or less not the problem. So it works. We have processes. So we have some companies that works, but the whole process, so how to get the material, what kind of fiber do we have in that material, a high modulus fiber or high tenacity fiber or whatever. So to have a really good commercial industrial process, we have a lot of things to work on.
Okay, so let's go on then. Birhan is joining us from Ethiopia. Wow, okay, cool. Then Balas is from Hungary. Very well. And I'm seeing that Yannick has greeted everyone already. Then we have Chikelui, I hope I pronounce it in the right way, from Nation Africa. Thank you so much, from Africa. And then Abdallah is asking what type of bikes they are producing, city bike, road bike, etc. And what about the ISO 4210? Shall we take Sven on this one in the group?
Yeah, I think that's a good idea. We are not producing carbon bikes, means we only produce city bikes, and I think the biggest target group is, for example, hotels and camping places, or people at hotel and camping places on sea areas, means where we have the salty sea wind, or people who always park their bike outside, because that is the biggest strength of the bike. And we want to use recycled material. We want to recycle it super easy again. I have, by the way, an idea how to get that. For example, we want to offer 50 euros for every bike which we get back. And means we definitely want to have a city bike, or we want to produce a city bike. And the weight of the frame is also not as good as the carbon frame. It's around 3.8 to 4 kilos. And of course, we test everything on the norm 4210. That is the norm, what is the most important one for us, and the norm for city bikes. And we have 25 testing machines in our production area where we test the frames. And if the tests are successful, we of course test it also externally with this norm.
Okay, so thank you, Sven, for highlighting this. So let's go next to Giorgio one more time. He says he has also solutions to valorize the dust from composite production and finishing. Is dust a big issue in composites?
Yes, it is. So there are a lot of investigations concerning how dangerous is the dust, the carbon fiber dust, with I would say with the result, it's not like asbestos, but yeah, it's good to avoid the dust, to get the dust out. So that's very interesting. Yeah. So yes, it is a problem. So that means what Jan Philipp said, not to, if it's not necessary to sand a bicycle frame and to finish it with a classic finish to prepare it for the painting, this would be a big thing to get it out of the mold in a high quality. That is that would be perfect. Or that would be, they can do it. So with technology, it is possible to do it like that. So it's a big thing. I talked to some.
And then we have,
yeah.
And then we have a former student of you, Oliver. He greets you.
Yes,
he's at, I hope he passed his exams.
Yes, he's at Bugatti. So interesting too. Sports cars.
Okay.
So it's a
so how about Bugatti? Do they also manufacture bikes, or why is Oliver today here?
So I think he's a composites enthusiast too.
So he's generally interested in composites
yeah,
technologies.
so he worked for some years for Bugatti, and yes, you know the company or the brand Lightweight. Bugatti did a special bicycle, so a special carbon frame with lightweight wheels to give it to their customers. So
yeah, I think every car
producer, but they're related to bicycles too.
Yeah, I think every car manufacturer should have a CO2 emission-free bike in their portfolio in order to reduce the CO2 of the Fuhrpark. Anyways, just joking. Okay, I think we've gone through these most of the comments. Then there are, of course, some thank you greetings and things like that. So everyone, thank you so much for attending to our show. Yes, then Marc, I would conclude the igus session with you and would come back to Arne, and we will meet you later again. So I will take now Arne and Yannick into the picture, because now let's move from the biking industry, where we had a deep dive on bikes. Let's move into other sporting goods. Arne, from your experience as an AI material process optimization company, where do you see opportunities to, increase the quality level of sporting goods with composites?
Yeah, sure. I mean, typically it's everywhere used where the typical production methods in composites are used, like RTM, autoclave curing, and so on, injection molding, as we learned as well. And of course, there's a huge variety of applications. It's not just bicycle, it's tennis rackets, it's hockey sticks, it's sometimes running shoes, it's especially as well motorsports. I mean, we talked about Bugatti, but of course in Formula One, they're the monocoques for decades, but also in other sports cars like spoilers and other applications. As I said, it's a huge variety of application in sports.
All right, Yannick, do you have, from your experience, by the way, Yannick is now a freelance expert with his company Catalysium. Congratulations on your startup, Yannick. And so I'm using Yannick always as a resource when it comes to different kinds of sectors. And I mean, he himself is a bike racer. Can we say that? But I asked Yannick not to talk about bikes, but anything else. So it must be hard for him to dive not into bikes. But let's try, Yannick. So what's your view? Where is composites particularly useful in sporting goods?
Thanks for the kind words, Ilkay. You're certainly an inspiration here, and let's be the co-pilot for today's show. So yeah, coming to sports, of course, I mean, I spent many hours on the saddle, but actually saddle is an interesting example, and then I will jump to another sport, because it's all about functions in composites. So sometimes it's about lightweight. Obviously, we over-focus on lightweight when we race bikes, but then there are also functions like rigidity, flexibility. And that brings me to the running shoe, for example. It's also true for diving fins, which also need some flexibility on one side for the kick, but also rigidity so that you really transfer the energy wisely. And that's what we see for a few years now in the running shoes at marathons or on the track. It's to have these blades in the sole, these blades made out of continuous carbon fiber, reinforced plastics, so either thermoset or thermoplastic, we see both. And these blades, they will give you rigidity so that you transfer the energy. You even have a kickback effect, kind of a spring effect. And that's why we see also the best times on those races going down over the years. So we are approaching the 2 hours in marathon running, I would say in official conditions. And that was not possible without this technological leap. So we see that in, obviously, in shoes that we can all buy. I think many of you already have this kind of shoes and feel the effect. Yeah.
Okay, let me then come to my last and probably the most favorite topic, and that is sustainability. Arne, what role does sustainability play in the sporting goods industry, particularly with composites?
Arne, you're mute.
So sorry. So what I just said is, I mean, it's a huge role. The whole industry, whether it's sports or not, needs to be more sustainable for a safe and green environment in the future. And there, of course, energy consumption takes a big role. We need to get the carbon footprint of products lower, and therefore, of course, the energy consumption during the production is a key role where our sensXPERT technology can help. And the other one, of course, is the recyclability, which we talked previously. I mean, there's a challenge for thermosets, but thermoplastics offers a huge opportunity for the recycling topic. But also, of course, also some issues appears there. I mean, they can be recycled more easily. But of course, if plastic materials have a previous life, they bring material variations to the process, and they also need to be handled somehow. And this is also where sensXPERT can contribute.
So, okay, we are already well over noontime, and it's time to wrap this up. So I'm getting now everyone on the screen. And let me just conclude this nice session here with full of experts. We've run through the sporting goods industry. So if you've attended our live at a later stage, in a few moments, you will be able to watch this on replay here on LinkedIn, but also on YouTube. And next week, you will have it on your ears as a podcast. Just listen to our Composites Lounge podcast. We have over 150 episodes on many, many different applications, materials, and so on already available. Join also our free group here on LinkedIn. It's free. It's online. So you don't need to commit contractually somehow. But let's build a ecosystem, a network of composites experts. And we always encourage the whole supply chain from raw material to end use to be part of this show here. So my last round finally is traditionally the call to action. What is a call to action? This is a social media term. Actually, I came across with it on social media. Basically, the question is, what should now the viewer who has listened to this, watched to this, do after they've enjoyed your information? So I will go again clockwise. Yannick, what is your call to action to our viewers?
I mean, for anybody passionate about these materials or wanting to learn more, the unique opportunities to come from March 4th to 6th to JEC World, the biggest fair in the industry in Paris. Yeah, just join the show, ask your questions, challenge the industry.
Excellent advice. Arne, how about you?
Yeah, I mean, everyone who finds himself in the position using composites, producing composites, whether it's thermosets or thermoplastics, reach out to us. I'm sure you can learn more about our technology, and we can discuss how it can help to increase your productivity, make the product more sustainable. Reach out to us, and we will be also at JEC at the Composite United booth. So please join us.
Yeah, many companies this year are on the Composites United pavilion. So great to see you guys all there. So Marc, what's your call to action? Professor Marc.
Yeah, so performance is important, but ask about sustainability in detail.
That's a really great one. And get those old sporting goods back to the manufacturer. Sven, I think you said you want to offer a 50 euros a bonus for someone who brings the old bike back. I think that's crazy cool. Yeah, do that. Then yes, Jan, what's your call to action?
Yes, well, to think about new technologies, to new production technologies, and how these can use to enable us to have newer and also more faster and 100% recyclable products.
Okay, and finally, Sven.
Yes, the stream starts with a video. Maybe after the stream, check out the video on YouTube, and you really learn a lot about deep insights, what we do here at igus.
Yeah, maybe Sven, you can put the link into the chat somehow, and then people can directly click on the link. So it's time to say goodbye, to wrap this session up. It was always enjoyed to talk to the engineers and the technicians and all these material experts out there. I'm always fascinated of what kind of knowledge is there. Maybe just a few words to say why I'm so heavily involved in this composites thing. So my 3 content pillars are innovation, technology, and sustainability. And as you can see, most composite materials are innovative. They have some production technologies, but not only production, also AI is a tech, is an IT tech, yeah. And then we have sustainability. So whenever I will be leaving this planet, yeah, and hopefully I still have some time, I want that this planet will be left greener and better than I came on this planet. And that's why I'm saying composites is a way to do this. And even the sporting goods industry, they are not producing any CO2. So sporting in itself is a sustainable and the most sustainable of all of our markets. Yeah, you play tennis, you don't produce CO2. You ride with your bike around in the woods, you don't produce any CO2. So sporting goods is the most sustainable one. And in my view, it's also credible to be a messenger and an advocate and an ambassador of CO2 reduction in this world. So when this world is over, then CO2 reduction should be also diminished. And that's my last word for today's. And I thank you, the panel, and I thank you, dear viewer and community, for watching us, and everyone who was giving their comments, introducing their solutions. Thank you so much for your activity. Stay tuned. The Composites Lounge Engineering Talks will be now going into a pause because we are all preparing now during February for the JEC World 2025, which has been mentioned several times. And in April, on the 10th of April, we will have the next Composites Lounge Engineering Talks, and that will go around automotive. And then we will have concluded aviation, infrastructure, construction, sporting goods, and automotive 5 before we are starting a new series of Composites Lounge Engineering Talks. You are welcome. Excuse me. You're welcome to send me a note if you have an idea for a new topic, and then we will take it from there. Thank you so much, and bye-bye.
Bye.